In section 9.4, we are going to compare two population proportions now. So far we've done means, now we'll look at proportions. And we're going to look at the independent sampling case. So you take two samples from two different populations. P1 hat, the sample proportion, is approximately equal to the population proportion P1. P2 hat approximates P2, and then P1 hat minus P2 hat estimates the difference in population proportions, P1 minus P2, where your P1 hat is success out of total, and P2 hat again is success out of total for the second population. Properties of that sampling distribution of P1 hat minus P2 hat is that the mean of that distribution is approximately equal to the difference of population proportions. The independent samples there have a standard error or standard deviation. The sigma P1 hat minus P2 hat is square root P1 1 minus P1 over N2 plus P2 1 minus P2 over N2 if P1 and P2 are known. If not, then we substitute the sample proportions in there. And then notice if we just took one piece of this, that is the standard error of the P1 hat distribution. And this is the standard error of the P2 hat distribution. So we're combining those together. By the central limit theorem, that P1 hat minus P2 hat distribution will be approximately normal if you've got large sample sizes. In other words, N1 P1 hat greater than equal 15, N1 1 minus P1 hat greater than equal 15. So that's successes and failures for the first population, and then successes and failures for the second population need to do the same thing. If that is the case, then your large sample confidence interval for the difference of proportions will be the difference of the sample proportions, P1 hat minus P2 hat, plus or minus Z alpha over 2 times your standard error of the sampling distribution, which is right here. Or if you don't know P1 and P2, here. Assumptions again, independent random samples, two populations, large N. These are the TI-84 commands. We will take a look at those in the example. If you want to do hypothesis test for difference in proportions, P1 minus P2, independent samples, P1 hat, P2 hat to find the same. We need that sampling distribution approximately normal. So independent random samples, each sample needs to be less than 5% of the population. And then this is the same large sample restriction that we had for confidence intervals. Now, when we find the standard error of P1 hat minus P2 hat for hypothesis testing, we're going to use a pooled estimate here, P hat, which is the total successes over total sample size. And then since we don't know P1 and P2 here, instead of using this expression for the standard error, we'll do P hat 1 minus P hat times 1 over N1 plus 1 over N2. So notice if you multiply this in times each piece, you'd get P hat 1 minus P hat over N1, and then P hat 1 minus P hat over N2. So it'd look just like this, except it'd be P hat, P hat, P hat, P hat. So then your test statistic is going to be P1 hat minus P2 hat, difference of the sample proportions over this standard error that we figured above. And then the TI-84 commands are here, and we will carry those out again when we look at the example.